then according to a color code and why widely different values are needed in different types of circuit.
Okay, so here we go, we get one thing that is common to us. We all know this. State that the flow of electrons is from negative to positive and
Positive.
is in opposite direction to conventional current. This one you know from I think class 7,
No, sir, 9.
9. You know it from 9, but we see that some students they also get it in class 7, right? Basic
Yes,
electricity
sir.
part, like circuit, little bit they get the idea. That time also they get this, and this one learning outcome C also you got it. Like in nuclear physics, you got beta decay, right? Beta
Yes, sir.
decay. So beta decay is electron, right? And
Yes, sir.
that one you got beta decay in electric fields and magnetic fields, how they behave, how they are deflecting. Same thing here, huh? Electron beam is also behaving same way like beta decay. So this is also known to you, right? Now this one E, learning outcome E, you got also this one little bit idea like how to calculate the uh, values from the oscilloscope reading, right? Number of divisions, if you know the you know, if you know the milliseconds, that is time base, then you can get what is the value of time period. That one we did, little bit we did in the last topics. So here you'll get it more applications here, more calculations here, and these three are known to you, and other three A, B, and F, these are new to you, like how you are getting electrons from hot filament lamp, metal filament, then what should be the conditions for this electron flow. Two conditions are there mentioned.
So A is further described in B.
Mhm. Then we have some other issues here. You see other learning outcomes. Can you read this part, Karim, from G to M?
Here, sir. Discuss the need to choose components with suitable power rating. Describe the action of the thermistor and light-dependent resistors and explain their use as input sensor. Thermistor will be assumed to be the negative temperature coefficient type. I.
Mhm.
Describe the action of a variable potential divider, potentiometer.
Mhm.
J. Describe the action of a diode in passing current in one direction only. K. Describe the action of a light-emitting diode in passing current in one direction only and emitting light. L. Describe and explain the action of relay in switching circuit. And M. Describe and explain circuit operating as light-sensitive switches and temperature operating alarm. Use the relay on the other circuits.
Okay, very good. Thank you so much. Now here we get power ratings. Power ratings, you got idea about fuse ratings before, right? In practical electricity, you got fuse ratings, right? Like
Yes, sir.
where we should use 3 ampere fuse, where we should use 5 ampere, 13 ampere fuse. So similar way there is power rating. Okay, how much power one appliance can absorb, or how much power it can tolerate. That one we're going to discuss. Then H, this one is related to thermistor and light dependent resistors. In our DC circuit, we discussed this about these instruments little bit. At least you know what is thermistor. What is thermistor? You got here indications also. Negative temperature coefficient type. That means thermistor is one type of resistor
which vary.
which resistance varies with temperature. If temperature
Oh, thermal
increases,
resistor is thermistor.
yeah. So if the temperature increases, the resistance decreases in thermistor. And light dependent resistor is similar to thermistor, but it is working with light.
According to
Not
light
the,
intensity.
yeah, it's not working with temperature, it's working with light intensity. So if the light intensity is more, then resistance of this type of resistors decreases.
So,
Okay. Yes.
so will we also learn that why the thermistor means becomes less means have a less resistive means less ohm in when the temperature increases and more in
Hmm.
when the means
It's
will we learn that why does that happen?
actually that one is not our syllabus covering in your O level. Only we know that this is how it is behaving. Okay, that's it. But why it is happening, that is not there. Okay,
Won't
there.
we even get a surface of it?
Yeah, of course, we can discuss a little bit about that one. And then we have a variable potential divider. We had idea about potential divider before. Now we are having variable potential divider. That means there will be one variable resistor, and using that variable resistor, the voltage can be also varied. Output voltage also can be varied using the potential divider rule. That one we'll learn here. Then we have diode. Diode is a very common thing in our electronic instruments, where we have you know, two junctions, P and N junctions, and it allows the current to flow in a single direction. Okay, that's why it is also called rectifier. Diode is also known as rectifier.
So it is like there are number of junctions from which number of junctions which are primary in one direction in one side of the diode and only one output wire on the other side which is
Yes,
secondary.
like that, and we will understand it in with diagram, inshallah. There is graph also, there is circuit also, to understand how the diode is allowing the current, how it is opposing. So it is allowing in one direction, that is called forward bias, and which one is not allowing, that is called reverse bias. Okay, and we have a special kind of diode, that is LED, light emitting diode. When it is simply behaving like a diode, but there is a speciality. If current flows through them, then it emits
They emit
light.
light.
Yeah, so this is special about this, it emits light if current flows through it. Normal diode, we don't see any light, but this LED, light emitting diode, it glows when current flows through it. Then describe and explain the action of relays. Relays, you have idea in electromagnetism. we got some devices where
We
electromagnet.
switch on a higher voltage circuit with the
Yes,
help of a lower voltage circuit.
yes, relays. You can remember, mashallah. So relays idea, now we got all these equipment separately. Now in electronics, we'll get them together in a single circuit. When we are getting them together, then its application or working is a bit more, effective, efficient, and more elaborate. Okay, that time we say this type of arrangement as electronics. Okay, look here at the last learning outcome. It is mentioned like that. Is saying light sensitive switches. That means here we will use LDR, and then temperature operated alarms. That means there we will use thermistors, and then we have using a relay or other circuits. That means this light sensitive switches, temperature operated alarms, they will also have some arrangements where there might be relay circuit also. So it's becoming more complex and more bigger circuit with these small functions. All together they will work together, and it is called electronics. Okay, now we are having here first we are having thermionic emission and cathode rays. Okay. Could you please write this heading, both of you? You write topic name, topic 24, Introductory Electronics. Then you write this heading, thermionic emission and cathode rays. Cathode ray means flow of electrons, right? Altogether, many electrons flow together. That is called cathode ray. So from here, you write this part. Write this heading, thermionic emission and cathode rays. Then you write this part. Are you done with writing?
Not yet, sir.
Look at the diagram. We have here heater. This is filament, hot filament. And this one is cathode. And from here we are having electron flow. We have anode with high voltage and vacuum inside. Inside this tube, glass tube, we have vacuum inside. Yeah, are you done?
Yes, sir.
Karim,
Yes, sir.
Okay, so look here. We have some more information about the cathode ray tube here. Can you read here? Karim, continue from here. In the CRT.
Yes, sir. In the CRT, cathode ray tube, heating the cathode gives the electron enough energy to become free of the surface. If there was no voltage applied, the freed electron would have formed a cloud around the cathode. The application of the voltage causes the electron to stream away from the cathode in a ray or beam. Of course, that leaves the cathode must eventually be replaced from the power supply.
So we are having here hot filament, and from this hot filament, metal filament, we are losing the electrons that is filled up by the cathode. Okay, the power supply. Is it clear to you? Here is the supply. Cathode means negative, right? And
Yes,
negative
sir.
means there is plenty of electrons stored here, right? That's why it is negative. So the electrons flowing from this hot filament lamp, that is filled up by this cathode. Okay, it will replace that place from this power supply. Now you see there is important thing here.
So that means that the amount of electron coming from the battery, the same amount won't go back to the battery.
Here we are getting the heater. Okay, heater, you see hot filament, right? And due to
Yes, sir.
this high temperature, we have the free electrons in the metal, right? Those free
Yes, sir.
electrons will uh, lost the bonding, right, from the metal, and those will become free here. They will become free now. They are coming out. That place will be filled up by the cathode ray electrons. Okay, cathode electrons. Is it clear to you?
Yes, sir.
Okay. Another thing is here said, that is, if there were no voltage applied, voltage means this positive voltage. If there were no voltage applied, the freed electrons would just form a cloud around the cathode. So this positive potential, high positive potential, is attracting the free electrons, right? Those became free. So these free electrons, they will go together like flow of electrons together, right? Electron beam. Is it clear? And that electron, yes, that electron beam is called cathode ray.
Light. Okay, cathode
Cathode
ray.
ray. Is it clear?
Sir,
Yes, sir.
Yes, yes. Tell me, please.
the electrons are going from cathode to anode, right?
Yes, yes, yes. Correct.
How is it? How is it going?
Uh, very good questions. Thank you so much. Look, here we have mainly the electrons are coming from the heater, right? Hot filament.
Yes, sir.
When we are giving high temperature to anything, that the atoms, the electrons, everything becomes excited, right?
Yes.
Isn't it? So the free electrons on the metal surface, they become, completely free from the metal surface. They come out right here. Is it clear? And
Yes, sir.
if we are not giving any positive terminal here, what we'll see that these are forming a cloud of electrons here inside this, isn't it?
Yes, sir.
So what we do, we give here positive potential so that these electrons are flowing. Other than making or forming any cloud, they are flowing towards the positive because electrons are negatively charged and this terminal is positive, right?
Yes,
So they will be attracted to this positive and they will flow. Okay, and
yes,
this
sir.
flow is not a single electron, there is beam of electrons. Okay, lots of electrons are together going. That's why it is called hmm, that's why it is called cathode
Cathode
ray.
ray tube.
Yeah, cathode ray. This electron beam is called cathode ray. Is it clear?
Because
Yes, sir.
the ray are starting from the
Yeah,
cathode.
yeah. Look, here we said already this one. Hmm. Thermionic emission. Already you wrote it, right? Thermionic emission is the mechanism by which electrons are set free from the metal surface of the cathode. Okay, by
Sorry, it is
heating.
written metal structure.
Hmm. Yeah, metal structure. Yes. So metal structure of
Um,
the cathode. By heating the cathode in vacuum, the electrons are given enough energy to break the bond holding them in the metal. So normally they have the bonding, and now we are having enough energy to break the bonding, and electrons now set free from the metal structure. Is it clear now?
Yes, sir.
yes, sir.
Okay. So if you are done with that, here you write, huh? If there were no voltage applied, free electrons would just form cloud around the cathode. The application of the voltage causes the electrons to stream away from the cathode in a ray or beam. Okay. Now this process is called thermionic emission. Huh? Why it is called thermionic emission? Already we got it here, right? Thermionic emission is the mechanism by which electrons are set free. So after you are understanding all these things, we can go to the next part. Should we go? Are you done?
1 second, sir.
If you ask me, then I feel good. I understand that you are uh, paying attention. You are trying to learn.
Yes, sir, done.
Okay, Abir, you are also
Yes, sir.
done, right?
Yes, yes, sir.
Now, this is thermionic emission process where we are getting the electrons set free. And we are getting cathode ray, electron beam also. Electron flow or electron beam, that is called cathode ray. Now, Other than this process, thermionic emission process, we are also having free electrons in some other ways. It's written here. Can you read please here, Abir? Note.
Electrons may be freed from material by other means than thermionic emission. The photoelectric effect is one way. Also, electrons can be emitted from the nucleus of an atom by beta decay. We will know about them in details in other place.
Okay, so there are more process to get free electrons or the electrons set free. That is photoelectric effect. Hmm. Photoelectric effect is done by solar cells, right? Isn't it? Hello?
What, sir?
Photoelectric effect we are getting in solar cells, like solar panels, you know, right?
Yes, sir.
So solar panels, how we are getting the electricity? By photoelectric effect. If we are giving enough energy, enough light, sunlight, then that is called threshold energy. If you are giving threshold energy minimum, then you will get the electron free, becoming free from the semiconductor surface. You know, in solar panels, we are using the semiconductor devices, right? We have.
Sir, I don't know much about it.
Yeah, you don't know. You will know it later in A levels A2. We have this photoelectric effect. Okay, and in beta decay, you got in nuclear physics, right? There you also got electrons, free electrons, right?
Yes, sir.
Okay, so that one you know. Only photoelectric effect you don't know that much. That's why we wrote here. We will know about them in details in other place. Okay, we just brought it here because some of the students are more advanced. Yeah, they have the knowledge about photoelectric effect. So they might ask us, sir, what about photoelectric effect? That's why we brought this idea. Is it clear to you now why we gave this note?
Yes, sir.
Okay, so that you can have at least a little bit holistic idea. That one you are saying surface, right? Correct?
Yes, sir.
Okay, surface idea you got little bit. Deep idea you will get later. Okay, now deflection of electrons in electric fields and magnetic fields. Electric field, it's very easy to understand, right?
Yes, sir.
As electron is
Like
negatively
repel,
charged,
like attract.
yeah, electron is negatively charged. That's why it will be attracted to positive terminal. That's it. It's very simple. You know it. And magnetic field also, you know, it's following the Fleming's left hand rule, right?
Yes, sir.
Magnetic field is here into the paper. You see right side diagram in focus. Magnetic field is into the paper. Then we have path of electrons. That means it is working opposite of uh, current direction, conventional current direction, isn't it? Hello.
Yes, sir.
Now you can apply again, though you know it, you can apply your left hand to apply
Yes.
Fleming's left-hand rule here. We said one thing, that path of electrons are showing opposite of current flow. Yeah, path of electrons are showing opposite of current flow. So you apply Fleming's left-hand rule. Your magnetic field is towards the screen, first finger or index finger towards the screen. Then current flow will be opposite of electron flow. So it is left side, right? Your current flow. Then you see your thumb is moving down, right? Isn't it? Are you checking?
Yes, sir.
Okay, your thumb is moving, showing down. So this direction is showing you the flow of electrons in a magnetic field. So now you draw this, write this heading. Write this heading, please.
Yes, sir.
Deflection of electrons in electric field. Only this part you write. Deflection of electrons in electric field. Then you draw this diagram. Just you don't need to draw like the book one. You just draw the way I'm showing here. You have negative, right? So you give
Yes,
here
sir.
just one line here, box. And here is negative. Hmm. Give some, not that much. You just understand it, right?
Yes, sir.
You'll understand it. Okay, so here you give positive. Then if,
Should I draw after the heading?
yeah, after the heading till this much you. So you draw here this way, the electron beam is going, huh? Is it clear?
Yes, sir.
Okay.
Sir, so was it only me who got disconnected?
Okay, no problem. You write it, huh? Deflection of electrons in electric field. You just simply draw this way, the way I showed. Not all these things
Sir,
details. Mm-hmm.
no problem, sir. I will just ask you that in the end of the class. It's out of topic.
Okay. Now, later on, we are having magnetic field, right?
Yes, sir.
Deflection of electron in magnetic field. You write this heading. Deflection of electron in magnetic field. Deflection of electrons in magnetic field. You just draw this right side diagram.
Sir, before it was written deflection of electron in current
In electric field.
in electric field,
Hmm.
and I would draw the diagram,
Yeah.
and I would draw that one which you drew here.
Yes. That one
Okay, sir.
simple. Just you give positive side, negative side, then show the electron flow. Now this one you are applying Fleming's left-hand rule, right? So you draw this diagram
Sir,
quickly.
in both of the time we will use Fleming's left-hand rule.
No, the first one is only positive negative. You see, electrons are negatively charged, then it is attracted to positive terminal. That's it.
Okay, sir.
And this one we are applying the Fleming's left-hand rule because we have magnetic field also. We have current flow. Then we are having the force, right, from magnetic field and current flow. So are you done with drawing?
Yes, sir.
Okay.
Almost, sir.
Yeah, this is magnetic field into the page. So we are having 10 minutes break. After this meeting, you join at 9:57. You join. 10 minutes break.
Yes, sir.